Now, if you've seen some of my previous videos, watched any of my talks, or seen my blog posts and stuff that I'm talking about on Twitter, I'm pretty interested in GraphQL and kind of using it as an entry point into different systems. And one of the ones that I'm really been working a lot with here at AWS is kind of using it as an API gateway into all of AWS Cloud. Now, I've shown you how to work with CDK with different databases like DynamoDB and RDS, Postgres, Serverless Aurora, but I haven't really gone into too much else. So in this video, I'm going to be looking at how to use Neptune as a graph database with AppSync as the API layer. Now, I am not an expert at graph databases, so I think the main thing to take away from this video is kind of really how to actually build out this infrastructure, put everything together. I'm going to run some really basic queries and also show how to insert data, but I'm not going to be going into a lot around how graph databases work. So I think once you get this up and running, you'll be able to kind of dive deeper into the fundamentals of how all of that stuff works. This video is really kind of meant to show you how to use CDK, infrastructure as code with TypeScript, to kind of build out all of this infrastructure, get it up and running, test it out, and then from there you'll kind of have a good understanding of how to build it from there, doing more sophisticated and complex queries and things like that. So with that being said, let's go ahead and get started by creating a new folder and initializing a TypeScript project. So I'm going to create a new directory called AppSync Neptune API or something like that. All right, so from here we can go ahead and initialize a new CDK project. So I can say CDK init, and I'll just set the language to TypeScript. All right, next we'll go ahead and install our dependencies. So the dependencies that we're going to be working with are AWS AppSync, AWS Lambda. We're also going to be working with AWS Neptune and AWS EC2. Now, the only reason that we're using EC2 is that we want to set up a VPC that our Lambda and Neptune are both going to be a part of. That way they can talk to each other. All right, let's go ahead and open up our project in our text editor. So the first thing we're going to do, we'll go ahead and go into the lib folder because this is where our stack lives and this is where we're going to be writing all our code. I'm also going to open up the tsconfig.json because I want to go ahead and set no implicit any to false because this is a video. I want to make it quick. There's a couple of areas where this would cause some problems in our Lambda function code in just a moment. So I'm going to go ahead and disable that for now. So here in our main stack, we're going to go ahead and import the imports that we're going to need. So we're going to go ahead and import the CDK core. We're also going to import AppSync, Lambda, EC2 to create our VPC, and then Neptune. And once we have all of that stuff imported, we can go ahead and create our API. So the API that we're going to create is a basic AppSync API. The authorization type is just going to be API key, meaning that anyone that kind of makes a request to this API using the API key in the header will be able to access it. So it's essentially kind of like a public API. If you want to learn more about how to implement authorization or multiple authorization types with AppSync, check out one of my previous videos. I created one a few weeks ago that kind of goes over how to do that. But we won't really be covering that in this video. The next thing I want to do is the AppSync API is referencing a GraphQL schema, and it's looking in this GraphQL folder for a file called schema.graphql. I haven't created that yet, so I'm going to go ahead and create a folder called GraphQL and a file here called schema.graphql. And in here, we're going to go ahead and create a pretty basic schema. We're going to have a post type. The post type has an ID, a title, and a content field. We're going to have an input type for creating a post. The ID will be created on the server, so the only thing we want to pass in is the title and the content. We're going to have a query and a mutation, one for listing posts and the other for creating an individual post. The posts will have a type of post input. And just for the heck of it, we'll set up a subscription just because any mutation with AppSync, you can easily add a subscription by just creating the subscription definition and adding this at AWS_subscribe directive. All right, so we're good there. So the next thing we want to do is we want to go ahead and create our VPC. So to do that, we'll go ahead and create a VPC right here. So we say VPC is equal to ec2.vpc, and then we give the VPC a name. So we might say Neptune VPC or Neptune AppSync VPC, whatever you'd like to call it. This is kind of going to be the ID for the VPC. Next, we go ahead and create a Lambda function. And here we kind of specify the VPC that we want to deploy this in. And then we set a couple of other things. We want the runtime to be Node.js. You can set it to whatever version you like, 12.x or 14.x. I'm using 14.x. I'm setting the handler code to be in Lambda functions folder / main.handler. We have not yet created that, but we'll create that in just a moment. Probably at the end of, after we're done creating our CDK code. I'm also setting the memory size to be bumped up a little bit from the default. So we're using the memory size of 1024. Now that we've created our VPC and our Lambda function, let's go ahead and create our data source. So the data source is this line of code here, where we're kind of going to say, for our AppSync API, we want to attach a data source. And once the data source is attached to our AppSync API, we can then attach any queries or mutations that we've defined in our schema to map into this data source. So a data source could be a direct data source. So it could be a DynamoDB table, Elasticsearch cluster, or a serverless Aurora. But in our case, we want to access different data sources than what AppSync supports first class. So we're just going to be mapping the GraphQL operation into the function. And then in the function, we can then talk to Neptune. So the two operations that we want to map into our Lambda function are list posts. So if we go to our schema, we have list posts. So when this query is invoked, we're going to be invoking the function. And then the other is create post. And then create post takes in an argument of post. So we have our two queries, or our two resolvers for our query and mutation created. We can go ahead and now create the Neptune database cluster. So to do that, we're going to be adding first the cluster definition, where we say new Neptune.database cluster. We give it a scope and an ID. We set the VPC, and then we kind of set the instance type. I'm going with what was in the CDK docs with respect to the instance type, so R5_large. I don't know a whole lot of difference between these, to be quite honest, but this seems to be what is recommended, so I think it should be a fine choice for this video. I then need to set where who can access this. So by setting cluster.connections.allow default port from any IPv4, I'm basically saying any connection within this VPC can access this. So this is kind of going to give access from our Lambda function into this Neptune database. I then am going to go ahead and get a reference to the two different addresses that are going to be created for Neptune, because we're going to need to have a WebSocket connection to read and write to our Neptune cluster. And once you've created the cluster, you can actually reference this address by calling by referencing cluster.clusterendpoint.socket address and cluster.clusterreadendpoint.socket address. One is a read-only endpoint, and the other is writable. So the reason that we need these addresses is in our Lambda function, we're going to need to reference the WebSocket connection using the URI. So to do that, we're just going to go ahead and create an environment variable that we're going to be using to reference the write and the read address. And then in our Lambda function, we can access this URI by saying process.env.writer and process.env.reader. And then we can now construct our WebSocket connection using those reader and writer addresses. The next two lines are not really required, but if you would like to kind of print out or use these addresses elsewhere, maybe in your some other application, maybe your client-side application, or wherever, or whatever you would need it for, I don't know, you can do that by using this cdk.cfn output. I don't think you're going to really need this anywhere because you're going to only be accessing this from your Lambda function, but did that anyway because I think printing out the CDK CFN outputs is often useful depending on what you're working with, maybe in different scenarios. So now that we've created that Neptune cluster, we're actually done in our CDK stack. So what we're going to do now is go back to our command line. And here we want to go ahead and create our Lambda functions directory. And we'll go ahead and change into that directory. And we're going to need to use the Gremlin package. So in order to install a package, we're going to go ahead and run npm init --y, which will create our package.json. And now we can just say yarn add gremlin. Actually, I'll go back in there because we want to go ahead and create a few files. So I'll create a file called posts.ts. I'll create a file called listposts.ts, create posts.ts, and also main.ts. And then now that we have those files created, I'm going to go into the Lambda functions folder, and we can go ahead and start plopping in or writing some of this code. So for the post type, it's going to be pretty basic. We have an ID, a title, and a content field, all strings. And we're going to be referencing this post type in our create post function. So with the post created, post type, we'll go ahead and go to create post. This is where we write some code that is specific to working with Neptune and also with a graph database. Again, I'm kind of new to how to interact with graph databases, so I've learned a lot over the last couple of days and couple of weeks. But we're going to be basically inserting some data into our graph database. To construct the API that we need to do this, we're going to import Gremlin. We're going to create a driver remote connection. We're going to then create a graph instance, or a graph variable, and then we're going to reference the URI here. So we're going to say process.env.writer, and then we're going to create a variable called DC, calling driver remote connection, passing in the address. Now the address is constructed using a combination of this WCC for WebSockets : // and then we reference our URI, and then we say /gremlin. And then we can now use the variable G that we created here by calling graph.traversal.withRemote, passing in the connection. And what we're going to basically do is we're going to say we want to add a vertex, I think it's vertice called posts. And we're going to say we want to add a title of post.title and a content field of the post.content. So we're saying we want to add the post title and the post content, and then once we're done, we're going to go ahead and return the post. But since our schema is expecting our post type to have an ID, we're going to go ahead and append a post ID by referencing the return value from the just created post, which will have an ID field that we can now just kind of use. You could think of it as like an automatically generated variable on the server. We're going to set that as the post ID, and then we're going to return the post. That way also, if a mutation is triggering a subscription somewhere, we have all the different fields that we need. So now that we've done create posts, let's go ahead and do list posts. So list posts is going to be where we just read the posts from our graph database. So we're going to go ahead and construct all of the things that we need to work with Gremlin again. We have all these imports. We're also referencing the URI. We're creating this constructed URI using the WSS and the URI and the /gremlin. Again, all this stuff. This is a lot different though, because we're going to basically be first calling and getting the posts, which is going to return an array, and then we're going to kind of map over the array here. And we're going to be getting the properties from each item in an array. And then we're going to basically be constructing a post object here. So we're going to basically say the underscore properties.reduce. This has a few different fields. It has a label, it has a value, it has a few other things. But the things that we're interested in are the label and the value, which is going to be something like title, and then the name of the post, content, and the name of the post. So we reduce the properties and create our own new post object. We then append the ID again because we do need that ID, which is part of the the value that we have here. And then we create an empty array of posts. And for every item that is returned in this array, we're going to just push a new post into that array, which is going to end up giving us the data structure that we're expecting from our GraphQL schema, which looks something like this, where we have this post with an ID, a title, and a content field. List post returns an array of posts. So we're kind of constructing that dynamically from the initial blank array that's coming back, or the basic array that's coming back from Neptune. We then return the posts, and that's it. As long as this works, we should be getting the data that we're looking for. And if it's an empty array, this should actually come back as an empty array. So there should be no errors, even if there is no data in the database. So the last thing we want to do to make this all work is like, how is the actual GraphQL operation going to be mapped and hitting list posts and create posts? The way that that's going to happen is in our main.ts. First of all, we import create posts, list posts, and our post type. And by the way, all of the code for this is going to be linked into the comments or the summary of this video. We also create a basic AppSync event object for our for TypeScript. The only things that we're really going to be working with are the field name and the post itself, and we'll take a look at that right now. So in the handler itself, we basically have two things that should happen in this function, right? We can either call create post to create a post. Like if we look at our schema, the only two operations that can happen are list post or create posts. So we want to take into consideration both of those. So how do we actually get that? How do we know like what needs to happen? How do we actually get this create post or this list post field name? The way that we can do that is we can look in the GraphQL info object, and we can say we want to switch over the event.info.fieldName. And if it is create posts, we want to invoke one function. If it's list posts, we want to invoke a different function. If we're not matching anything, we'll just return null. So we're going to basically say if it is create post, we want to go ahead and invoke that create post function that we just created earlier that talks to Neptune. And we're going to be passing in the event.arguments.post. This is that object that holds the ID, well actually not in this case the ID, but the title and the content field. If it's list post, we want to call list post and return that array. And that's really about it. Not a whole lot of code or complexity happening here. I really like working with this interface because it's really simple to kind of look at and understand what's going on. And you can build this to be as complex or as large as you'd like it. A lot of people also take the route of creating a separate function for each operation. So you can go that route as well. And instead of having to switch every single time this function is invoked, you would just call one database operation. You would know exactly what that is. There's a lot of different discussions around the trade-offs. We're not going to get into that right now. So we should be ready to go. So I'm going to go ahead and close all these files, make sure I save everything. And what we want to do is we want to go ahead and compile this. So to do that, we can go ahead and open our terminal, and we can run npm run build. And this will go ahead and compile our TypeScript into JavaScript and make sure that there's no errors or anything like that. And once that's done, we should be able to go ahead in our code and just see that we have all these additional files. Our .js files have been compiled and all that stuff. So we're good to go there. The next thing we might want to do is just see the things that are going to be created. So we can run CDK diff and kind of see that we're going to have, these different resources that are going to be created. So we see that we have a Lambda function, we have our Neptune stuff, we have our EC2 stuff, bunch of stuff that's going to be created actually. So to go ahead and deploy this, we can now run CDK deploy. And I think this is going to go ahead and prompt us with a few different things. And we need to go ahead and say yes to go ahead and deploy this. And we'll go ahead and choose yes. And now we wait. All right, so once the API has been deployed, you'll see that you have kind of a couple of outputs. These are just those outputs that we had defined earlier. But for us, really what we want to do now is go ahead and test this thing out. So to do that, we can go ahead and open up the AWS console. So I'll go ahead and bring a window over here. We're going to go into AppSync. And we should go ahead and look for Neptune API. And we're going to go to queries. And we'll go ahead and create a mutation for creating a post. And the post is going to have a title and a content field. And we should be able to return an ID, a title, and a content field. And then we should also be able to query for list posts with the ID, the title, and the content field. Okay, so let's go ahead and create a couple of posts. And we see that the data is coming back. We have our ID that's automatically generated. And if we call list posts, we can see that we have our array of posts coming back. So we have the data that we want to return. So if we only wanted to return the title and the content field, everything works like you would expect with any GraphQL API. So that's about it. I kind of wanted to kind of just run through the fundamentals of getting this stack up and running, showing you how to do some really basic stuff. But I think for me, before I learned how to do this, I was kind of curious just how this all worked together, because the more different data sources I understand how to use, the more robust of an API or an app that I can build, and I can access these various data sources for different types of use cases. So again, I really enjoy this stack. You're going to see a lot more of this from me, I think, in the future. And I appreciate you checking out this video. If you learned something, please subscribe and share my video. And until the next time, I will see you around. Thank you.